Hello and welcome to the Simpson Strong Tie training video, part of the connector training for Contractor series. Throughout this series, you'll learn basic installation techniques for fasteners, joist and beam hangers, mud sill anchors, plated truss connectors, and hold downs.
After watching this video, you'll be familiar with the terms that are often used on job sites to discuss and describe trusses. You'll also be able to identify some common truss types and to install a variety of Simpson Strong Tie truss hangers and bracing products correctly. The products referenced in this video have our standard G90 coating, but are also available with Simpson Strong Tie's Z-Max galvanized finish or in stainless steel. If you're not sure which product to use, check the corrosion information supplied with this video. A metal plate connected wood truss is an engineered pre-built component that functions as a structural support member in a house. Let's look at the parts that make up a truss. The primary parts of a truss are called chords and webs. Chords are the perimeter members of a truss. The top chord is an inclined or horizontal member that establishes the top of the truss. The bottom chord is an inclined or horizontal member that establishes the bottom of the truss. Webs are members that join top and bottom chords. Toothed metal connector plates tie a truss's webs to its chords. There are different names to describe where truss members intersect. For example, the place where a web meets a chord is called a panel point. The place where a top chord intersects with a bottom chord is called a heel. A bearing is a load-bearing wall or beam that carries truss loads to the foundation of the structure. Where a truss intersects with a bearing is called a bearing point. Note that structures also have non-load-bearing walls, which are called partitions. There are two types of truss bracing, temporary and permanent. Temporary bracing holds trusses in plane until permanent bracing is put in place. Permanent bracing stabilizes trusses throughout the life of a structure. We will refer to truss members as either supporting or supported. A truss member with a hanger attached to it is a supporting member. A truss member that you install into a truss hanger is a supported member. Trusses are designed to resist many types of loads. Lateral loads are forces that push on a structure. Uplift loads are forces that try to lift the truss away from its bearing points.
Now that you're familiar with basic truss terms, let's look at some common truss types.
A variety of truss types are used in construction all throughout the country to build floors and roofs. You should be able to identify the common trusses that we are about to review because it's important for correct product installations. A girder truss is usually made of multiple trusses, which are fastened together to act as one truss. A girder truss carries heavy loads from structural members that are framed into it. In symmetrical hip-set roofs, a hip jack is installed at a 45-degree angle from the corner of a structure to the hip girder. I'll refer to the hip jack simply as the hip later on in the video. An end jack extends from the end of the building to the hip girder or hip jack. We will refer to the end jack as the jack later on in the video. A valley truss sits on top of other trusses. It's used in construction to change the direction of roof planes or to connect diverging roof planes. A gable end has a triangular-shaped frame. It's used in construction to complete the end wall of a building and has vertical members that support the sheathing and resist wind.
Now you're familiar with some common truss types that you may see as we learn how to install Simpson truss hangers. It's an engineer's or truss designer's job to specify truss hangers. but it's your job to install the truss hangers that they specify correctly and in the right places.
Before you begin installing any trusses, verify that all the specified hangers were delivered to the job site. Hanger specifications are usually located in one of three places: on a truss placement plan, in the structural design document's fastener schedule, or on the individual truss design drawings.
The erection of wood trusses is dangerous and requires careful and proper installation methods. The Building Component Safety Information Booklet and summary sheets provide guidelines for the safe handling and installation of trusses and temporary bracing. Please take some time to become familiar with these resources. In just a few moments, I'll show you how to install Simpson strong tie truss hangers. However, let's first look at the hangers themselves.
The HUS is a face mount hanger that has the dome nailing feature to guide nails at a 45-degree angle. Like the HUS, the HTU is also a face mount, but it doesn't have dome nailing. It has straight nailing, but otherwise installs just like the HUS. To install, place the hanger on the supporting truss and install the required nails through the side flange nail holes into the supporting truss. Then, place the supported truss in the hanger and install the required nails through the domes so that they enter the supported truss at a 45-degree angle. This is what the HUS looks like when it's installed correctly. Adjustable truss hangers have long straps, similar to head or flanges on typical face mount and top flange hangers. These hangers are called adjustable because you can field form the straps to create top flanges, which will give you the installation benefits of a top flange hanger. All THA series hangers have straps and side plates. It's important for you to recognize these parts because I'll refer to them as I explain the installation processes. THA series hangers have two different installation methods: maximum and minimum nailing. The maximum nailing method is similar to the installation process for a typical face mount hanger. After you position the hanger, drive the appropriate nails through the strap nail holes and into the supporting member. Then place the truss in the hanger and drive the appropriate nails through the side plate nail holes and into the truss. Note that the side plate nail holes are designed for double shear nailing. Therefore, you have to drive the nails at a 45-degree angle so that they go through the corner of the truss and into the supporting member. Take a moment to review this complete, correct installation. Installation requires that you field form the straps over the supporting member. This makes the THA series hangers like a typical top flange hanger. Before you begin installing any THA series hanger using the minimum nailing method, you should know how many inches of strap must extend over the top of the supporting member. To secure the hanger, install at least 4 10D commons through the straps and into the face of the supporting member. Bend the straps over the top of the supporting member, then drive at least 2 10D commons through each strap and into the top of the supporting member. The minimum nailing method for the THA-29 requires double shear nailing. You must drive 4 10D commons at an angle through the side plates so that they go through the truss and into the supporting member. Here is what a correct installation looks like. Note that for all other THA models, the minimum nailing method doesn't require double shear nailing. When this is the case, you can easily straighten the double shear tabs and drive the nails straight into the truss. For single-ply trusses, use 4 10D by 1.5 nails. For 2-ply trusses, use 6 16D by 2.5 nails. The THAR/L 422 series of adjustable truss hangers is designed for the standard 45-degree floor truss installation. In both the maximum and minimum nailing configurations, you must field form the straps at least 2.5 inches over the supporting member. To finish this installation, drive 1 10D by 1.5 inch nail into each pan hole and 1 10D by 1.5 inch nail into the side plate. The THASR/L series of adjustable hangers are designed to connect trusses that are severely skewed. These hangers can be field skewed between 45 and 84 degrees. There is a 4-step process for installing this product. Place the supporting truss in the seat of the hanger. Align the back edge of the supported truss with the slotted holes in the side plates. Then drive 4 10D by 1.5 inch nails into the side plate nail holes to fasten the hanger to the truss. Install 10D nails into the header on the acute angle side of the hanger. Adjust the hanger to the desired angle. Bend the obtuse side of the hanger flush with the supporting member and install the face nails. Bend the strap over the top and install the rest of the required nails. Here's what a correct, complete installation looks like. Heavy truss hangers, part of the THG series, connect the supported truss to a vertical member of the supporting truss with bolts or SDS screws. To install a THG series hanger, place the hanger into position and mark the machine bolt locations, then drill the bolt holes. When bolts are required in the supported member for additional uplift, drill the holes using the same process that we just covered. Secure the THG to the supporting member using the bolts. Then place the supported truss in the hanger seat and install 10D commons through the side plate nail holes and into the supported truss. Take a moment to review this correct THG installation.
Now let's complete this section on truss hanger installation by learning how to install multiple truss hangers.
Multiple truss hangers connect hips and/or jacks to girder trusses. Two common multiple member truss hangers are the LTHJA26 and the THJA26. Let's look at how to install the LTHJA26. The LTHJA26 has oblong or oval-shaped nail holes. Oblong holes make installation easier because you can drive nails through them at an angle. The LTHJA26 series hangers have fastener holes located in the seat of the hanger and require installation of fasteners into the bottom of the hip members. To install, first position it on the supporting member. Then install 20 10D common nails into the face of the supporting member. Place 2 hips or a hip and jack into the LTHJA26 and fill all the nail holes with 10D by 1.5 inch nails. To finish this installation, install 1 10D by 1.5 inch nail through the seat of the hanger and into the bottom of the hip member.
While correct hanger installation is critical to overall truss installation, bracing is equally important. Let's look now at bracing products and installation. When erecting trusses, temporary and permanent lateral and diagonal bracing is required. It is a building designer's or designer of record's responsibility to provide a permanent bracing plan.
Lateral bracing is installed at right angles to chords and web members to provide stability, and to help a truss resist lateral movement, and to prevent trusses from leaning and causing the domino effect. Bracing also prevents a truss from bending out of plane. The typical S-bend is a warning sign that trusses aren't properly braced. Even trusses that have lateral bracing can buckle in an S shape if there's no diagonal bracing. Therefore, lateral bracing requires additional stability from diagonal bracing. Now let's look at how to install two of Simpson Strong-Tie's bracing products, the TSB2-24 and the TBD20. Used properly, these products meet the requirements of BCSI for bracing trusses. You can use the TSB2-24 as lateral bracing for top chords, bottom chords, and web members. To install the TSB2, you will use only 10D by 1.5 inch nails. Start the installation by placing the brace on the top of the top chord or bottom chord. Next, secure the bracing by driving 2 nails through the 2 nail holes at each end of the brace.
If web members require permanent lateral bracing, the truss design drawings will indicate which webs to brace. Note that you can install the TSB on either side of the web members.
Here's what the TSB2-24 looks like when it's correctly installed. Note that you don't need to remove the TSB2-24 before you install the permanent sheathing diaphragm. Its profile is low enough that you can sheathe over it. The TBD-20 is a diagonal brace that safely transfers loads from the TSBs to the supporting structure. Note that the TBD-20 installation requires that you use only 10D by 1.5 inch nails. The TBD-20 is installed on a row of 5 trusses. To begin installation, determine where to secure the TBD-20 on the first truss. Hold one end of the strap next to a TSB on the top cord. Ensure that the strap is tight, and then install one nail through the bracing and into the top of each truss. Then insert one end of the strap through the clip. Secure it by installing 2 nails through the interior clip section and into the cord. Next, install a second strap clip on the side of the last truss using 4 nails in the exterior clip section, and secure it with 2 nails in the interior clip section. This completes the installation for a single brace. You install the TBD-20 in an X configuration between parallel rows of TSB2-24s. Therefore, repeat the installation process in the opposite direction to form an X. Like the TSB, the TBD-20 has a low profile, so you don't have to remove it before applying the sheathing. This is what the TBD-20 looks like when it's installed.
Now let's discuss some truss uplift connectors. Uplift connectors resist forces that try to lift a truss away from its bearing points. Let's take a look at some of the Simpson uplift connectors and how to install them.
The H2.5A is a symmetrical uplift connector. This series of truss connectors attaches to the sides of the truss. The H2.5A installation requires either 8D common or 8D by 1.5 inch nails. To install, align the plate line on the H2.5A with the top of the top plate. Secure the H2.5A by driving 5 nails into the top plate and 5 nails into the truss. The H10 and H14 Series truss connectors encapsulate the truss much like a joist hanger. The H10 installation requires that you drive 8 8D by 1.5 inch nails into the plates and another 8 8D by 1.5 inch nails into the truss. You can install the H14 either to a double top plate or to a double 2x header. To install the H14 to a double top plate, position the bottom flange tightly against the bottom of the double top plate. Then install 12 8D common nails through the face of the H14 and into the double top plate. You must also drive 1 8D common nail into the bottom flange. Finish the installation by driving 12 8D by 1.5 inch nails into the truss. To install the H14 to a double 2x header, first straighten the bottom flange. Then align the seat with the top of the 2x header. Next install the H14 by nailing 15 8D common nails into the header and another 12 8D by 1.5 inch nails into the truss. If your walls are constructed using concrete or CMU material, embedded truss anchors like the META-20 provide a simple solution for the difficult wood-to-masonry connection. After the grout is placed in the cells, insert the hook of the META-20 into the grout until the embedment line makes contact with the grout. After the grout is cured and the trusses are in position, bend the strap up and over the top of the truss if necessary. Ensure that the strap is tight against the top and sides of the truss. Then install the required nails into the single-ply truss. For multiple-ply trusses, note that you would use 16D common nails. Valley trusses sit on the sloped surface of other trusses, which can make connecting them difficult. The VTC2 makes this connection easier and resists uplift. You install the VTC2 on top of roof sheathing in accordance with the following 3-step process. First, align the center line of the VTC2 with the truss top cord. Then install the VTC2 using 4 10D common nails. Next, adjust the upslope stirrup vertically and attach the VTC to the bottom chord of the valley truss using 10D by 1.5 inch nails. Then, to finish the installation, adjust the downslope stirrup vertically and attach it to the bottom chord with 10D by 1.5 inch nails. Look at the correctly installed VTC2.
Now let's discuss some other connectors that were designed for special applications. Some types of connectors in the field can be challenging or time-consuming. The STC simplifies the process and provides an improved connection where a roof truss spans over a partition wall.
A truss should never be nailed directly to an interior partition wall unless the building plans call for it. The STC supports the top of a non-load-bearing wall while allowing vertical movement of the truss cord. Notice the slot and the nail holes, which you should be familiar with for correct installation. To install the STC, first place it on the top plate. Position it next to the truss. Then install 2 8D common nails into the top plate. Next, install one 8D common nail through the slot into the STC and into the truss. Install this nail in the middle of the slot. Don't seat the nail head. There should be a gap between the nail head and the STC. This gap will allow the truss some movement. This is what the STC looks like when it's installed correctly.
Now, let's review what we've learned.
You're now familiar with the basic terms associated with trusses. You can also identify some common trusses and correctly install a variety of Simpson strong-tie truss hangers and bracing products.
I hope that this video was both enjoyable and educational, and that you're able to apply what you've learned on the job. Thanks for your interest and attention. Goodbye.